In this video, I would like to give you an overview of using Jupyter Widgets to connect interactive graphic controls to your code. So you can access it through the Jupyter Meets the Earth webpage. There's a few different ways you can run it. You can click on the launch button here, and you can run that online on Binder, or you can run it in the page with the live code button. Alternatively, you can download the notebook and run it locally. And so that's what I'm going to do, and I've got it running in this tab over here. And so what we're going to look at is data from Mauna Loa, the CO2 record. So there's been CO2 measurements made at Mauna Loa for quite a number of years. And we're going to look at these data. And what we want to do is actually give a bit of an overview of linear regression using some data. And so this will be the motivating example that we'll use to show you how to use widgets and connect those to your code. And so these data are originally from the script site, and you can download the original data source here. I did some light formatting and cleanup so that our analysis is easier, but the original source is here. So we go ahead and we're going to import the packages that we need, and in particular, the one that we're focusing on today is the IPyWidgets package, and I'm going to import that as widgets. And then here in this next cell, all we're going to do is load up the data and print some information about it. So we'll print here what the first year is and what the last year is. And so in the data set that we're looking at, we've got data from 1958 up until 2020. And then I've just created a couple of helper functions where we're going to be able to grab a subset of the data between two different years and go ahead and be able to plot that. So let's look at the whole data set. So here we can look at the whole data set, and we can see this is the seasonally adjusted CO2 measurements in parts per million over time, so from 1958 till 2020. And so the question we're going to ask is, okay, let's say that we take the first 5 years of data. If the trend between 1958 and 1963 were to capture the trend of CO2, what would we expect the CO2 concentration, atmospheric CO2 concentration, to be in January 2030? So let's look at those first 5 years. And so all we're going to do is we plot those up, and you can see that that looks like it's a bit of a linear trend, perhaps. And so we're going to see if we can fit a line to those data. And so then what I define is we've got two functions here. We've got a function where we're going to basically just be able to add a line to this plot. And then we'll plot both the CO2 data and the line together so that we can start to compare our fits. All right. So up to now, we've basically just been running sort of standard Python code, NumPy, Matplotlib. And now what we're going to do is we're going to actually use widgets. And so in this case, what we're going to do is we're going to go ahead and set up basically an interactive control where we're now actually able to go ahead and adjust the slope and the intercept of our line to try and sort of see if we can use the eyeball norm, use our eye to fit what we think the trend is. And so this could be used perhaps in an educational example. You can pose some questions about, okay, so what are you actually using to assess the goodness of fit? And how might we translate that into something mathematical? So we go ahead, we've got our slope and our intercept here, and we want to now perhaps make a prediction. That was the original question we asked. If this is the trend that captures everything that's going on with atmospheric CO2, what do we expect perhaps in the year 2020? So here we're going to go ahead. We've got the year that we want to predict. We know how to make a prediction based on a line. And then what I do is I actually grab the values from the widget here that we were working with so that we can basically assess this interactively. So we grab those values and then we can go ahead and make a prediction. And so the prediction in the year 2020 is 370 parts per million if we modeled that, or if those first 5 years captured the trends we want to capture. So let's actually ask the question then, how does this actually compare with the data? And so you can see that does a pretty poor job predicting quite far out. And so again, if you were talking about this in sort of an example, learning about linear regression, we could pose a few questions. Why are these so different? Which regions do you actually think that we perhaps maybe trust that linear trend versus not? And then maybe what sorts of things would you do if we actually do want to try and fit this trend over over many years, what would you try and do? So there's a lot that just happened there. And I want to show you, and we're going to break down now a bit of what just happened with widgets. And so we're going to start by using the interact function. And so what this does is it basically lets you connect up graphical controls to your functions. And so we've got a simple function here where we've got a function f of x, and all it's going to do is multiply x by 3. So if you pass, so interact, if you pass this function and then a value for x, so here we're passing it in integer, what you're going to get back is an integer slider. And so in this case, we can slide over, and we can see that that's updating and multiplying x here by 3. If instead we passed true, false, it's going to give us a checkbox. So you can see it's basically inferring based on the type of what you are passing, what a reasonable graphical control should be. And so here, if it's a string, for example, we get back a text field where we can enter that. You can also use interact as a decorator. So here we've used it as a decorator, and then we provide the values, the default values that we want it to work with here. And you can see again, if x is true, we're going to get a checkbox, and if y is a float, we get a float slider. If, for example, we only wanted to explore one parameter and keep something else fixed, we can use the fixed function. And so what that does is it just holds the q value fixed at 20 and only gives you a graphical control for p. Now, these were basically trying to infer what if you provide an integer, you get an int slider. If you provide a Boolean, you get a checkbox. So it's trying to, interact is trying to infer what kind of widget makes sense based on what you've provided. But if you wanted to customize that further and provide a specification of what you want, minimum, maximum values, the step size, and the default value, you can do that by specifying actually widgets specifically. And so here's just a table that shows you basically what the defaults are depending on what you provide for inputs. If you provide a tuple, it's going to go between the min and the max here, so between 0 and 4. Those are both integers. If you provide 3 elements, so a tuple here with 3 elements, the step size is then going to be the third element. And then this is also true. You can do the same. You can do the same for floats. Oops. If you pass a list of strings, what you get back here is we get a drop-down menu that's going to pick either of those. And then we can start to compose those a bit more. Sorry, what we can do here is we can also pass basically a string and then what we actually want that to evaluate to. So if we have 1, that actually passes a value of 10. So if we have a choice of between 2 things, and then 2 passes a value of 20. So in addition to interact, there's also the interactive function, and that is what I used above in the Mauna Loa example. And what this actually does is if you actually want to be able to go in and access the values, either the inputs or the outputs, and reuse those later in a computation, this is what you want to use. One important thing to note is that unlike interact, the widget is not going to display automatically. You actually need to call it to display. So here we're going to create a new function that's got 2 values. We can create a widget instance, but you'll notice that didn't display. What we actually get back here is that this is an interactive, which is a subclass of a container. So this is basically a container for the widget. And then we can see that it has 2 children, and these are going to be what we can actually interact with. So if you want to display that, then we can actually just go ahead and call display on the widget. Or alternatively, in the notebook, you can also just enter W, and it knows to display that automatically, and we can work with that. So here, then we can go in, we update our values here, and we can then ask what are our keywords, our keyword arguments. And so this is what I used above to pull out the slope and the intercept from the widget that we interacted with. And then similarly, the result is stored here on the result. So if you needed to use either of these, either the inputs or the results, later on in some sort of computation, you could go ahead and do that. And then this is just another simple example showing you, very similar to what I showed above, of how to actually connect interactive to a plot. And so here we're plotting a simple line interactively. The last thing I want to touch on is disabling continuous updates. So for example, if you have something that's a slow function or a big computation, but you still want to be able to work with it using widgets and running interactively, we can actually disable continuous updates. So here we can see that we've got some slow function, and we can call interact manual. That's one way to have sort of the continuous updates. And by continuous updates, I mean here, as I slide over, we can see that the line updates continuously. Whereas here, if I move this value and then I do run, I have to run interact before I get a value out. So again, if I move it, this is not updating interactively, you are not updating continuously. You have to then hit run interact for it to rerun. Another way to do this is you can also pass a dictionary with manual equals true to interactive. And you will get the same behavior where we get this run interact button. Finally, if you perhaps had multiple widgets in that are being passed, that you're passing arguments, and perhaps one of them is expensive, but the rest are very cheap. What we can do is pass just specifically a continuous update equals false for on that specific widget. And we can take a look here and see that it waits for a moment before updating. And there's lots more in the documentation, so I would encourage you to take a look.